Now we have two types of motions. One is uniform motion, other is non-uniform motion. One is uniform motion, other is non-uniform motion. Now what is the difference between two? Uniform motion is that when body travels equal distance in equal intervals of time. When body travel equal distance in equal intervals of time. For example, if suppose we say that suppose we are going to certain place, this is my distance, this is my time, right. So I say that when the time is 0, suppose the distance is 0, but when the time is 1 second, or suppose we take in kilometer, I am just going to take in kilometer per hour, right. Suppose we are going traveling to Delhi, if I say, so suppose when my time is 1 hour, let's say that my distance is 30 kilometer. When my time is 2 hours, suppose say my distance comes out to be 60, and suppose when the time is 3 hours, my distance comes out to be 90. So we see that there is an equal time interval, and moreover the body is traveling equal distance. So we say that body is having a uniform motion, because as you can see that in each hour it is actually traveling 30 kilometers. In each hour it is actually traveling 30 kilometers. So we say that motion is uniform. So that means body travel equal distance in equal intervals of time. And if we plot a graph for it, it comes out to be a straight line graph, because the body is traveling equal distance in equal intervals of time. For example, body moving at, or a car moving at 30 kilometer per hour. So that means the motion is uniform, because in each hour it is actually covering 30 kilometers. Now what about non-uniform? Suppose if I plot again a same graph like this, suppose this is my distance time, again distance expressed in kilometer, time in hour. So let's say when time is 0, distance is 0. When the time is 1 hour, let's say distance comes out to be 30 kilometer. When time is 2, then the distance comes out to be, let's say that suppose 40 kilometers, and suppose when the time is 3 hours, a distance comes out to be 100 kilometer. So that means the time interval is again same, because it is in our hand to keep a watch. But the distance here between 1 and 2, it covers only 10 kilometers, and between between the second and the third hour, it covers 60 kilometer. That means it just speed up. So that means this is called as non-uniform motion. That means when body travel unequal distance in equal intervals of time. Time remains equal, intervals of time is equal, but the coverage of distance is unequal. For example, a car moving on a busy road, suppose lot of traffic is there, and sometimes the car just speed up, and sometimes car just stop. So that is the reason we can say that body is moving with non-uniform motion. Likewise, we can have an example, aeroplane landing on a runway, because we know that whenever when the aeroplane is in air, it has very high speed, but when it touch the ground, the speed just gets lower, and finally it stops. In the same way, aeroplane taking off. So when the aeroplane just starts, it has a lower speed, then it goes on increasing, and then it increases to a large extent. So this is all the example about non-uniform motion. And if you plot a graph for non-uniform, it comes out to be a curved line, that is the parabolic or a parabola curve. Parabolic is the curved line where there is unequal distance in equal intervals of time. That means they do not vary directly along with each other, they just have different values at different intervals of time. So this is what is the uniform and non-uniform motion. Now we are going to start with another topic, that is the speed. What is speed? Speed is actually distance travelled by body, distance travelled by body in given time, or we say with respect to time. Suppose I write a formula for it. So, speed is distance upon time. If we use symbols for it, so speed is v, distance is s, time is t. And if we look for the the units, so we know that distance is expressed in meters, the smaller unit, and time is second. So that means unit comes out to be meter per second, or the bigger unit comes out to be kilometer per hour. So this is what is the speed. Now speed is again of different types. We have uniform speed, we have non-uniform speed, we have average speed. Uniform speed and non-uniform speed is just similar to uniform motion and non-uniform, exactly same, equal distance in equal intervals of time, unequal distance in equal intervals of time, same graph, same example, same everything. But what is average speed? Average speed is total distance covered by body in total time. Suppose I say that I am traveling to Delhi, and my distance from Chandigarh is 250 kilometers. So it comes out to be, suppose I am traveling a 250 kilometers, and the total time which is taken by me is 3 hours. So that means my average speed comes out to be 250 is my total distance and time is 3. So this will suppose let us say x. So this is x kilometer per hour is going to be my average speed. That means average speed is the total distance with respect to total time. Now as you can see that speed depends upon distance, and distance is scalar quantity. So that means distance is a scalar quantity. So we can say that actually speed actually give a good amount of information, but not a complete information, because it is a scalar quantity. Scalar quantity does not specify the direction, it is actually an incomplete quantity. So we need a quantity which gives the same thing as the speed does, but it should be a complete quantity, and that quantity is velocity. And that quantity is velocity. Velocity is a complete quantity because it specifies magnitude as well as direction. So what is velocity? It is distance travelled by body, same like speed, distance travelled by body in given time and in given or specified or in a straight line or in a particular direction, whatever term you can use. It means only a one direction. So velocity is distance travelled by body in given time but in given direction. So if we write a formula for it, it comes out to be velocity equal to distance in given direction, because the direction is specified, with respect to time. And you know that distance in given direction is also given a special name, that is the displacement. So we can also write velocity is displacement upon time. If we talk for the symbols, so velocity is again denoted by v, displacement is again s, and time is t. So as it depends upon displacement, it gives a particular direction. So that means it is a vector quantity because it specifies magnitude as well as direction. Now if we talk about its types, if first we will talk about unit, the same units as the speed has, it also has the same units, meter per second and kilometer per hour. Now if we talk about its types, then it is again of three types: uniform velocity, non-uniform velocity and average velocity. Uniform velocity and non-uniform velocity is exactly same, but what you need to write is in given direction, in given direction. That means in both the cases everything is going to be same, but you will be writing in given direction because you have seen that velocity take into consideration the direction also. So whenever you write here in given direction, it becomes uniform velocity, and same in this case. And if you talk about the example also, so here you need to specify the direction also. So body moving at 30 km per hour along north, south, whatever you can write. That means you need to specify the direction also. Similarly here you need to specify the direction. But what is average velocity? Again the same, it is total distance upon total time. It is total displacement upon total time. The same thing, because average speed depends upon distance and velocity depends upon distance in given direction, that is the displacement. So just the difference is the total distance in given direction you can write, or you can write the total displacement upon total time. So you will be getting an information related to average velocity. So this is what is the velocity. Now we have one more thing, that is the, I will just rub here. We have acceleration. What we have? We have acceleration. Now what is acceleration? Acceleration is actually rate of change of velocity. It is actually rate of change of velocity, or you can say it is change in velocity with respect to time. So acceleration is noted by A, it is change in velocity, rate means divided by time. So here the unit becomes, change in velocity unit is meter per second and unit for time is again second. So it comes out to be meter per second square, and as a bigger unit it comes out to be kilometer per hour square. So this is what is an acceleration. Now we have two kinds of velocity I must discuss here. See, one is initial velocity, other is final velocity. Suppose I say a body starts from rest and accelerates and its speed becomes 30 km per hour. So rest means it was not having any kind of velocity. So we say that initial velocity is 0, because initial velocity is noted by u and initial velocity is that which it possessed earlier. So it comes out to be 0. Final velocity is that which is the end one. So it comes out to be 30 km per hour. In the same way, and it is noted by v. Suppose I say a body is moving at 30 km per hour, it accelerates and its speed becomes, let us say, 60 km per hour. Then initial velocity u is 30 and v is 60. Likewise, if I say body is moving at 60 km per hour and suddenly comes to rest, then initial velocity is 60 and final is 0. So in the same way you need to make out that is the initial and the final velocity, and we can put here also. So this acceleration formula can become change in velocity means final minus initial divided by time. It can be written in this way also, final minus initial divided by time. And moreover, you know that there is a term which is related to, which is just opposite to acceleration, that is retardation. As you can see here that body is accelerating from rest, its speed is increasing to 30. Here its speed is increasing from 30 to 60, then 60 to rest. So that means we can have a term retardation also. Retardation is that when velocity decreases with time, when velocity decreases with time. It is just similar to acceleration denoted by A only, but it is a negative acceleration. That means we need to put negative because speed is decreasing. So in all these three cases, this case is of retardation because here the speed is decreasing from 60 to 0. So this is a retardation. So whenever we talk of retardation, it means velocity decreases with time. And if you wish to draw a graph for retardation, how you are going to draw? Suppose here I am going to draw. Suppose you have velocity, time, velocity, suppose initial velocity is this and you are just going to decrease it. So graph becomes like this. That means it is decreasing with time, and it is same as that of acceleration, same unit meter per second square, same representation A, but you need to put the negative sign. So this is what is the retardation. Now if we look for equations of motion, we have actually three equations of motion given by Newton. There are three equations of motion given by Newton. First equation is V is equal to U plus AT. Second is S is equal to UT plus half AT square. And third is V square is equal to U square plus 2AS. So if I say that this is the first Newton's equation, you need to write that this is the first one. You should not jumble the numbers. This is the second one, this is the third equation of motion given by Newton. And in all these all cases, you know that V is final velocity, we already discussed here also, U is initial velocity, A is acceleration and T is time. Likewise, S is distance, U initial velocity, time, acceleration, time, final velocity, initial, acceleration, distance. So this is what you need to specify, and moreover we will be taking some numerical problems now. Before we take, I just want you to remember one thing: anything that starts from rest, that means its initial velocity is 0, and anything which comes to rest, if you have say that a scooter moving at 30 km per hour and suddenly brakes are applied and it comes to rest, so comes to rest means final velocity is going to be 0. And if you get a question like this, a body is moving with constant velocity. Body is moving with constant velocity, that means velocity is not changing. So in that case, acceleration is going to be 0, because acceleration is change in velocity, but the velocity isn't changing, so we can write acceleration is equal to 0. Likewise, if you have this thing, suppose I say one more thing, starts from rest, comes to rest, constant velocity, and moreover if I say that there is a retardation, so you know that retardation is that you need to put minus sign in front of A. So this is what are the three